yes anyway, because I have no power over that. Okay, I counted like 30-something people in here, so I'm going to keep waiting for more people to join this Kahoot. Keep waiting and passing out these surveys. There's no rush on these surveys. You have 2 hours to fill them out. I collect them at the ends. Yeah? You just use your phone. Yeah. Does anyone not get a survey? There we go. Not that many meme names on this Kahoot. I'm just slightly disappointed. Find a meme name? You can't come up with a meme. You can't just come up with a meme name off the top of your head? Come on. Oh, that's very topical. Anyone still trying to join? I'll give it like another minute. Join this Kahoot. Join this Kahoot quick.
Oh God, thanks. Okay.
Does everyone have a survey? Did I miss anyone that just came in? Okay. There you go.
Can I have another one? Because my friend's
Absolutely.
Thank you.
All right, we're going to start in 15 seconds. All right, here we go. Starting with an extremely, very deep computer science questions. Which classical order is characterized as being the most ornate? It's the Corinthian order. Did no one Google that after he just randomly mentioned that stuff in class one day? columns. Yeah, it's these. Do you remember him talking about these? This last one is the Corinthian order. And that's all I know about these. This is straight from Wikipedia. Okay, good job, you 7 people. And almost clever. That person's almost clever. All right. Which of the following lines of code will crash your program? Good. What's that? What's happening in the red? Yeah? To a pointer? You can't point to null? Well, what's the stuff on the right side of the equal sign is what's making the program crash. What am I trying to do on the right side of the equal sign? Yeah? I'm trying to dereference null. I'm trying to go to null, which is a place I'm not allowed to go to. Where is exit defined? It's in standard lib. What other functions are in standard lib? Malloc? I heard someone say rands. srands. Yeah, I think those are from standard lib, yeah. Calc is in a standard lib, yeah. Free is in standard lib. I think malloc and free are the 2 big ones you should know that are from standard lib. What functions from time.h? Time. What functions are from stdio? Printf, scanf. Those are not in stdio. Do, while, for, those are just parts of the language. Those are not functions. Yeah. What's in exit.h? Trick question, doesn't exist. Exit.h doesn't exist. That was just to throw someone off with this problem. Rami is in the lead. Which of the following is the proper order? This doesn't have to do with columns. Well, actually, it does have to do with columns. My bad. It's rows then columns, yeah. There's like a vocabulary word to do with this. Does anyone know what it is? Row major. C is row major. And I guess you could think of C being as like in the blue, but everyone in the world thinks of it as this, rows then columns, so it's better to just do that. What can the 2D be replaced with to print APA to the screen? Ooh. Okay, can I show this? Maybe I should have given you a little bit more time for that one. Okay. So we have a character array of size 4 that's just got APA in it. Just some counter I. We're looping 4 times, every time printing a character. So right here, this needs to be a character. So if we just put APA, that would have been just wrong. This could have been a %s, but that would have printed APA 4 times, right? Array in brackets I. Our array is named R, so that won't work. Array J. The J looks a lot like an I, so I put that in there on purpose. There is no J here, so that wouldn't work. So what the heck is happening here with star R plus I? What's going on there? Who can break down what that does? What was it you want? Can I zoom in? Yeah, I can. Star R plus I. array sub I is what that does, yeah. But it's a long way of doing it without any square brackets. Does anyone know what's happening here? There's a vocabulary word for this. We're doing a dereference, yeah. That's happening. That's what the star is doing. We're dereferencing a pointer. Yeah? We're offsetting. The I is offsetting by array. This is called pointer arithmetic. So array is a pointer. All arrays are just pointers to the first spot. And then we're just adding I to that. So we're just doing some arithmetic to the pointer. And then we dereference the pointer is now pointing to an array starting at I. And then we dereference that. That's what's going on here. All right, what's happening in this code coming up? So that might have been mean saying that blue was wrong. But necrophilia is definitely happening here. So we have a double pointer, and we are using. This is going to. You can use double pointers to store a 2D array, yeah. But we make space for just one integer pointer in here, right? Times 1. And then we just go to that one index and make space for one int. So technically, we're just really making space for one integer, right? We just have a double pointer to it for sort of no reason. Does that make sense? Where's the necrophilia happening? Yeah? The last line? Specifically, what part of the last line? When you freeing it, or when you just access it? Yeah, just accessing it. Because on the previous line, the third line, you're freeing the array, and now you've got no way to access sub-0. So you're going to a dead thing and doing necrophilia. All right. Which of the following ways can we not create a student? So there's a student struct here. Yeah, we can't just say students do. What's wrong with saying students do? Like that. Yeah? Because it's capitalized, yeah. The type def student is a capital S, but this student is a lowercase s, so it doesn't match up. If we want to use the lowercase s student, you've got to use struct student stu like this. So this is correct. You can do struct student stu like that, because this lowercase student is attached to the struct, all of the structs, and this capital S is its own thing, type deft. Ooh, Rami went down. Okay, which of the following ways can we not create a student? Slightly different struct this time. Yep, you can't do struct student stu. Why can't we do struct student stu now? Yeah? It's only under the type def, you mean? Okay. You're sort of close, but not quite. Yeah? It's an anonymous struct, yeah. So I can't say the word struct at all for declaring a student. Struct student stu, there is no struct student. That doesn't exist. I can only ever do student stu, like this, like these three. That's an anonymous struct is the keyword there, the vocabulary word. And I just ripped this totally off of his last lecture. Okay, I definitely need to add more time to these, sorry. All right. So how would you set Stu's pointer equal to the address of his ID? And of course I did it in a completely convoluted way without using any arrows. So you've got a struct student, he's got an ID, and he's got a pointer. They're both ints, but one's a pointer. And you've got a student struct that is a pointer also. So you can walk through what's happening here from so let's work inside of these parentheses. What's happening here first? That's what's going to get evaluated first. We're dereferencing the struct, okay. And then we're going to the pointer inside the struct, and we're setting that equal to, we access, oh wait a minute, what the heck? Oh no, I'm so sorry. This is not good. Oh no. Okay, this question's wrong, sorry. Because I can't just do stu.id like this, because stu is a pointer. Okay, I messed up. I confused myself. All of these are so bad. All right, last question. Everyone knows the number 1, of course, right? But what's the number 5? Oh, everyone click the number 1, though. Dandelion Community Cafe is like number 9 or something. But Krung Thep's number 5, and that's my personal like number 2. I really like it. Wendy's isn't on the list, and I don't like Wendy's either, because it's fast food. But Krung Thep is really good. It's got it doesn't have a Mama Ling Ling's Thanksgiving sandwich, but everything else it has is like better than Pom Poms, if you ask me. But it does not have a Thanksgiving sandwich, unfortunately. And that's the whole Kahoot. Good job, Rami, who has been in the lead basically the entire Kahoot. Good job. Okay. So I've got a pretty sweet review for you. And my review's been posted on my WordPress for like a week now. Does everyone know how to get to my WordPress? Okay. Well, it doesn't matter if you do or not, because I'm going to show you anyway. If you just Google UCF SI, it's the first link. By the way, this is the site for all the SI leaders. So if you got other classes that are any of these, there's an SI leader forum. They've got their own review going on probably soon. Anyway, right here is mine under CECS, Intro to Programming with Jarrett. These are all the times I've had all semester, but no more. But you can look at this and think, oh, I could have studied with him. And these are all my reviews. Here's the one I'm going to do today. And definitely do check out my past reviews, because they're still relevant, because this exam is cumulative. I know my exam 2 review has like a really good problem on file I/O. Yeah, this one's like really complicated and long and good. And I have solutions posted for these, and an ominous blank spot on my site right here. Who knows what I could put there like 30 minutes after this review is over at 6:30. Who knows what I could put there, you know? Could be anything. All right, any questions before I start? Cool. All right. write a function that repeatedly asks the user to input strings, so like just type in strings in the command line, store them in an array. When the user types stop, the function, the loop has to stop accepting user input, and then just print all the strings that they typed in back to them onto the screen. You can be guaranteed that none of the strings will be more than 127 characters, so that could help us. And the tricky part of this problem is that we want the array storing the strings to have no wasted space at all. So we want it to be able to store exactly as much space as the strings that we're putting in and stuff. Does that make sense? Any questions? Any ideas how we can tackle this? Yeah? Uh-huh. Mm-hmm. Yeah. Yeah, we're going to do that. So there's, I think, 3 major functions that we're going to, no, 4 major functions. I guess 5 functions in total. Yeah, 5 functions that we're going to use. Who can name all the functions that we're going to use in this program? Yeah? What was that? We're not going to use chomp. Sorry. Maybe you're super into chomp. We'd have to write chomp, first of all, because we don't have that given to us. Yeah? Printf and scanf, so there's 2. We're going to use a loop, yeah, but that's not a function. What about the part about it saying that the array is going to have no wasted space? Yeah? fgetS? No, we're not going to use that. Maybe there's a way we could use that if we wanted to. fscanf. We're going to use just regular scanf, but we could use fscanf if we want. If we wanted to, we could go crazy and use that instead of regular scanf. What about the part about comparing the stop to make sure that we have the string stop? We're going to use string compare. All right, and there's 2 more functions we're going to use, and they both have to do with the part about the array having no wasted space. Yeah? malloc and free. We've got to use malloc and free on that array a lot. Okay. So, I think what I'm going to do is I'm going to leave this area up here mostly blank for now, because this is where I'm going to put all my variables. But we definitely know that we're going to need our array of strings, right? So that's going to be a 2D array of characters, and we're going to use malloc and free on that a lot. So we should declare it like this: char star star strings. Okay. And we also need to store like the current string that they just typed in. And I'm just going to do that statically. Like this. Why did I decide for it to be 128? Yeah? The null sentinel, yeah. So we guaranteed that it's not going to be more than 127 characters. So you need a 128th character for a null terminator at the end. Okay. Now we're going to have an infinite loop. This is going to be our loop. This is how I like to do infinite loops. So we're going to have a loop that goes forever until we get something that we're going to make the loop stop. All right? So at the beginning of every iteration of the loop, we will scan. All right? So we just asked, we're not even going to ask, we're just going to just wait for the user to type something in, type in a string, hit enter, and that'll go into inputs. All right. Now is when we need to see if they typed in stop, right? Because we don't want to put stop into our this array here. What should I put there? I want to see if the input and stop are equal. Zero, yeah. If it's equal to 0. When would it return something not 0? When they're different, yeah. What can you say about if it's a negative number, though? If it returns a negative number? I think you're right. I honestly don't know off the top of my head. I think that just seems intuitive to me. It's probably that way then. Well, that sucks. Why aren't they all the same? All right. Anyway, so if it's equal to 0, then they're the same. That's all we have to worry about now. So if they're the same, what do we want to do now? It's just a one-liner inside of here. Yeah, break. Cool. All right. So at this point now, we've got our input. We know it's not equal to stop. We want to put it into our array. Okay? So here's the thing. If our double array here of strings, first of all, you'll notice I never made space for it in the first place. So do we know yet how many strings we're going to put into our array? No, we have no idea. We'll only know when they type stop, but by that point, we've lost all of the strings that they typed in, so we can't wait until they type stop to figure out how big the thing needs to be. So any solutions to this? Yeah? Uh-huh. Mm-hmm. Mm-hmm. Yeah, you would. But you're really close. You're onto it. I feel confident that if this were a question on your exam, at least, you'd be able to figure this out. But I can't say that about anyone else here because no one's speaking up. So yeah, we've got our 2D array of strings here. So how about this? Let's make enough space for one string. And then for that one string, we just make enough space for our input. And we'll just put our input in there. And then the next iteration of the loop, we make enough space for one more string and put our new string in there. And then every iteration of the loop, we make enough space for one more string. The problem with that is we have to like re-malloc the entire array every single time. Every single time. So what we need to do then is we've actually got to have two double pointers. One for like the old array and one for a new array. So when we make space for a whole new array that's exactly the same size as the old one plus 1, we copy everything over and then we free the old array. that make sense? Okay. Okay. And we need two ints. I'll say this length will be equal to 0. This is going to be the length of our array here. Because we need to keep track of how big it is. This is going to increase every single time we get a new string. And we're going to need an I at some point, because we need to loop through our old array to put everything into the new one. Okay? So here's what's going to happen. We're going to first set our old strings equal to the strings. So this is what actually makes old strings, is this line right here. And now we make new strings our new strings. Like that. I forgot something. Did I forget to increment length? I think I did. No, I'm good. Oh, wait. Ah, crap. Like that. All right. So right now length is 0. We're going to increment it in a bit. So for now, we're just going to make strings enough space for the size of a char star times 1, because right now length is 0, so plus 1. Now we're going to copy all the old strings over. And the thing is, we don't actually need to copy them, because they're just pointers. So what's going on here is we've made enough space for our new strings. And length at this point still has the length of the old amount of strings. So we're just going to loop through the amount of the old amount of strings, which is the length of this array. And we're just going to copy in all the pointers. We don't need to do string copy, because we're just going to move pointers around. Does that make sense? Okay. And now we can free the old strings. And this just deletes the reference to the array of old strings, the array of pointers that was too small now. It doesn't delete the actual strings themselves, because they're each in their own pointer inside the array, whereas deleting the references to those pointers. Okay. Now, what we've done so far is we've just copied over all the old strings. We still haven't even saved our current string yet, so that's what we're going to do next. So length, if right now it's the length of the old string array, that just happens to be the index that we need to put the current input. All right, so we make enough room for our input that we just got, so just the string length of the input times size of char. That should just give us enough space for this one string that we've been given. We finally do a string copy. And now we can increment length. And this, I'm going to run off the page, but this is the end of this for loop that started way up here. So this is the loop. This should be the end of the loop that gives us all the input strings. Any questions about this? Because this is the hard part of this problem, because the next part's easy. We just print out the strings. Yeah? What was that? No, I have no line numbers because I don't write as big as I type, as my printer does. But here, this is where we set old strings equal to strings. So whenever this loop last mallocs space for strings, like right here, on the last iteration of the loop, this malloc happened, and now old strings is equal to that previous malloc. And that's what this is freeing right here, is that previous malloc that we did in the last iteration of the loop. Yeah. So everyone's good on this? I know you can't be. This is super complicated, right? Calling malloc inside a loop, you're calling malloc like a gazillion times. It could be a gazillion. I could sit there and type strings a gazillion times on my computer, and malloc would get called every single time. Okay. All right. The next part's easy. We just need to print all our strings back to the screen. Screen. So at this point, length should be as long as our array, because we've been updating it every time. So that's handy. And make sure to clean up when we're done by freeing strings. No memory leaks, no wasted space in this program. Any questions? I'll go back to the part that you probably do have questions for, but you're too shy to ask. Because if you do have questions, please ask, because there's probably like 7 other people that have the same question, but they're like, no, I'll sound like an idiot if I say that. Yeah? Sure, okay. All right, so we need the program to loop and have us type in words, pressing enter every time, and it's going to store those, and it's going to stop looping when I type in stop, and then when that happens, it'll echo them back to the screen as like evidence that it stored them, right? the strings that I typed in. So that's what this loop does. We've got an infinite loop, just a for loop with nothing in it, yeah? Yeah, but then I give strings a new address, right? When I call malloc. So now strings has a new address there. And old strings is holding on to the old address. Okay, so I hope everyone's cool with this part where I'm just scanning in and seeing if that is equal to stop or not. And when it is stop, I just get out of the loop. Okay. So what's happening here, I set old strings equal to strings. Let's start with just the first iteration of the loop. So what value does strings and old strings have in the first iteration of the loop? It's storing something right now on this line when I've created them. What are they storing? I know you know. Say it louder. Garbage. So right now, strings and old strings just has garbage. All right. So I set garbage equal to garbage, which is just meaningless. And then I give strings like something that's not garbage. I give it enough space for length plus 1. Length is currently 0. So I give it enough space for one string. Now I'm going to loop through the length of the old string, which is what length the len variable right here has, which is currently 0. So this loop won't run at all. And then I free old strings. Actually, this is probably bad. This is a memory leak. Or this is a segmentation fault, because I'm trying to free a pointer that is garbage, which is bad. Yeah. I needed to set old strings equal to null to avoid that. Okay. Does everyone see how that would have been bad, freeing a garbage pointer? But if it's null, free is like, cool, that's a null pointer. I know to not do anything with that. So I think this whole part right here is this is the complicated part of the function. Is this part like clear to everyone now that I've gone through it a second time? Okay. Okay, cool. I will move on then. So, what you should be doing as a safe C programmer, whenever you open a file with like FOpen, you should be checking if the pointer that function gave you is null. Because if it is null, then you can't do anything with it. You got a null pointer. But I personally found that super annoying that whenever I call FOpen, I need to check if it's null, and I just got tired of that. So how about we write a function that just like wraps around FOpen, that takes the same parameters as FOpen, 2 strings, returns a file pointer just like FOpen does. But what this one does for us is it already checks if it's null, and it's going to end our program if FOpen failed. Because that's what we would have done anyway, right? If FOpen failed, we probably would have just returned 0 from main, right? We've just ended everything. So let's just make a function that does that for us. So we don't have to, maybe in main we got to open like 7 files, and that would just suck, typing in if it's null and all that every time. So there's one key function here that we're going to have to use. Who knows what it is? What was that? This function will call FOpen. Yeah. And it will return what FOpen returns. But what it does for us is it's going to check if what FOpen returned was null. and it's going to end our whole program if it is null. What was that? FOpen? Oh, yeah, we're going to use FOpen, yeah, definitely. But what about the part where we're just ending our whole program? Exit. We're going to call exit inside this function. Okay. So I'm going to need a file pointer. And I'm just going to name this FP. Because, like, instead of IFP or OFP, I don't know if this is going to be an IFP or OFP. Because this function's going to make both for us. It's going to make us all sorts of file pointers. It's going to make us every type of file pointer FOpen can make. So first I'm just going to call FOpen, because that's like the most important thing that this function does. Easy. I just pass in the parameters that the function was given. All right. Now I need to check if that's null. And this is the part where we call exit. And we could give it an error like -1 or something. And we could like printf something. An error message if we wanted. Oh no. And then we just return the file pointer that we opened. Is that cool? Yeah? Exit just ends the program. Whatever. Yeah. I just feel like we're exiting with -1. You shouldn't put in 0, because that means 0 means that your program executed correctly. That's why you return 0 from main.
So does that return to anywhere?
Wherever you ran a.out on your terminal, right? Yeah. Yeah? How would you call that? You would just call that just like you would FOpen. So however you would normally type FOpen, if instead of typing FOpen you just type FOpenSafe, pass it the same parameters you would have given to FOpen, this will work. Yeah? Yeah, returning a file pointer. This is a function that returns a file pointer, yeah. That's probably something you haven't seen before. But something you can totally do. The same thing, however you would have normally called FOpen. So, you know, you can call FOpen like this. And say I want to open it for reading. That's how I would call FOpen normally. If you literally just replace this with FOpenSafe, it's exactly the same. It takes the same parameters as FOpen. Yeah. Who can think of a situation when you wouldn't want to call FOpenSafe? Yeah? If it doesn't exist? If the file name doesn't exist, then maybe it would have returned null, and we would just exit the program. That's actually the reason that we have this function, is so that it'll do that part for us, and we don't have to check if it's null. This function should never return a null pointer, because if it does do that, your program ends. But there is a situation where you would not want to call FOpenSafe. A situation that would cause a memory leak. if main, oh, yeah, if you didn't close it afterwards. So maybe like, what if you have, what if you have a second file open, right? You've called you've called FOpenSafe once, and it succeeded, and then you call FOpenSafe a second time, and it fails. Well, it's just going to end your whole program without closing the first file, right? So you're still going to have that first file open when your program ends, which isn't great. So this is really only good if you only ever open one file in your whole program, which I guess really limits how useful it is. Maybe you could have like a third parameter that's maybe an array of all of your open files, but now this is getting really complicated and kind of not worth it. Okay. Well, then it just knows how many open file pointers it's created. It needs to actually know all of the open file pointers for it to close them, right? Also, what if you have like just a random array that you made space for in memory, and you didn't free that before this thing terminates your whole program? Yeah. So this function isn't great, but I mean, if you get tired of only opening one file and then checking if it's null, and you write the same code over and over again, this is kind of convenient. So you don't have to do that. Okay. Any more questions about this? Okay. So let's say I have a person. I have a person struct. Like this. Made of two structs. So a person has a name and a person has a height. And there's nothing else to do with a person than that. That's as complicated as people get. They have a name and a height, and there's nothing else to us. And a height is in feet and inches because we're in America. And pretty much everything is pointers. So let's make a function that creates a person. You pass it in a name, you pass it in a feet and inches, and it returns a person pointer, a person struct. With everything initialized, it's got its name, it's got its feet and inches, it's got everything going on. Okay? What is the first line going to be? Well, I guess you should probably see the struct. It'd be helpful. What's the first line of this function going to be? Okay, yeah. Yeah, we could do that. Well, actually, okay, if we just make a person, that's got a height pointer inside of it, right? Yeah. So we've already got the second pointer when we make the first one. Okay. I'm going to name him just P. Okay. So I've omitted the semicolon because we're going to keep writing. What should happen next? Yeah? Yeah, we're going to malloc. So we've got to make space for a person. And this is going to be real simple. Like, because you could be thinking, oh no, how do I get enough space for a person, right? I've got to do like size of char star plus size of int plus size of int. And you're wondering, do I do that? Is that right? That sounds like the worst idea ever. No. You can just say size of person. And now you've got enough size for a person. And it's way easy. All right. So now I've made space for a person. Now, how does this sound? I can just say P name equals name. I can just set this name equal to that name that was passed in, which is right here, and everything's good, right? Everything's not good, yeah. What could be, I mean, I guess you could say that this is right, but what could be bad about this? Any idea what could be bad about this if this were to be what you did? I mean, I guess since I never specified it in the question, this maybe would be right on an exam and you'd get full points, but yeah. Well, this name is just a pointer. So we're just setting this pointer equal to that pointer, yeah? It's a string? Well, yeah, it is a string. And you can't just set equals for a string for assignment. But the thing is, this is just a pointer. So we're just setting this pointer equal to that pointer. So now this name and that name just point to the same string. And that itself is the problem. They both point to the same string. Because what if this name here changes? What if this name is like something I'm reading in from scanf, right? Well, next time I run scanf, I'm just going to overwrite that name with another name. And now this person here has a new name because I scandef'd a new name. So what I want to do is actually copy this name over. So I want to copy this name into this one. So I actually have two separate strings. What's something I have to do first before I can copy it, though? I got to make space for it. I got to have space to copy it into, which means I'm going to call malloc again. Okay, so I just call malloc just the length of name times char, so it's that many chars is how many space we need for this name. Okay? And now I can str copy p name. Just copy this name into our space we just made for this name, and everything's good now. Okay. Now, so we've done the name, just need the feet and the inches now. So, how about this? Our feet and inches are inside of a height struct, and our height struct is inside of our person. So how about if we did p, oh wait, not name, what am I doing? P height How do I get to the feet from here? Dot feet. Like that. Is that good? Doing height dot feet? Because height's a pointer. So we need to do arrow feet. Height arrow feet equals feet. And while we're at it, let's do the inches. Okay. Does that look confusing to anyone? Maybe you've never seen that before, like having two arrows in the same line, right? You're like 2 levels deep. You've got a pointer struct inside of another pointer struct. That's exactly why I made this problem, because that happens all the time, and it could happen on your exam. Any issues you see with what's going on right now? Yeah? Oh yeah, wait. Oh yeah, I think you're right. Yeah, I think you're right. Let's do that. I don't have +1 like that. Good catch. Yeah. You totally need to do that. That would have been like a point off on the exam probably. Thank you. Okay. That wasn't what I was looking for though. Yeah. But that's even better because I didn't know about that. Now I get to put that into my thing that'll be posting 30 minutes after this. I've left a blank space here for a reason. If I told you that this program is very likely to segmentation fault, let's call this lines 1, 2, 3, 4, and 5. What line do you think it would seg fault on? This line, where you do a string copy? What do you think's wrong there? Okay. You're wrong. I don't know. Sorry, didn't have a softer way to say that. But it's going to seg fault on this line, actually. What is making this line seg fault? Well, oh, you want to see the struct? Yeah. So it's going to seg fault on line 4. Yeah? I got to make space for a height. Height is also a pointer. So I've got to make space for the height also. This little innocent, these two innocent little structs here, I've got to call malloc 3 times. Yep, okay. Now I've made space for a height. And all that's left now is to return our person. It's just return our person we made. Easy. Any questions about this function? This function has been an exercise in calling malloc and nested struct pointers. And now we get to delete our person. We get to kill our person. So we need to get rid of all that space we malloced. So how does this sound? How does this sound? We just do free person, we're done. You're shaking your head. Yeah, we got to free the height and the name because we malloced those too. We've got to free every single thing that we malloced. For every call to malloc, there has to be a corresponding call to free. Okay. I freed height. I freed the name and the height. Is everything good? Yeah? Yeah, I got to put those above it. What is going to happen if I try to run this code? Yeah? Yeah, necrophilia. Because I'm gonna go to a dead thing. I'm gonna go to the person that we just killed them. This is a very, very necrophilic code right here. Okay. I'm gonna get rid of that necrophilia, and I'm going to call that up here. Okay. Is everything good with this function now? Yeah, what if person is equal to null? What if the person that I passed in is equal to null? What will happen if the person I passed in is equal to null? I mean, like if this function that we're calling delete person, we pass in a null person. Yeah. What if we pass in a null person? What's happening here? I think someone said it. Necrophilia. If we passed in a null person, then the first line there where I have person, I try to go to their height, that's necrophilia. The person is dead. We freed them. Does that make sense to everyone? I feel like that one wasn't as obvious as the previous necrophilia. So what we've got to do is just make sure that they're not dead. Yeah. All right. And if they're not dead, then you can do whatever you want to them. That's because it's our code, and we make the rules here. How does this code look now? I've omitted some things. I have omitted a semicolon, but I've omitted the semicolon because there's something else missing from that line. I need to return a person. So how does that work? Delete person returns a person. Why? Why would I do that? So you can have null, yeah. So right now all this function returns is null. And down here needs to return null also. Why do we want this to return null? To always return a dead person. Yeah? Yeah. So that's why we're returning null. But why are we returning anything? If it's always returning null, why not just return nothing, right? Not quite. It has to do with when we're calling it. Imagine how you call this function. How would you use this function? So the pointer actually looks at something? How about this? How about we've got a how about we've got a person? Okay, who wants to volunteer their name for this? I know we've been talking a lot about necrophilia. I'm sorry. Who wants to volunteer their name for this? Okay, what's your name? What was that? Josh. No, wait. Jose. Okay. I definitely misheard you. All right. Okay. So let's say I've got Jose. I'm going to delete Jose. Like that. And I'm also going to set Jose equal to deleting Jose. Do you remember why he said in class that this is what people like to do? Yeah? Yeah, it sets it equal to null like at the same time. Because we like to set our pointers equal to null when we're done with them. That way we know we can like check them. We can check them if they're null. So if we didn't have that, if this was just void, we would have had to have done delete person Jose Jose equals null. And people don't like doing that. You would have to, this is just 2 lines instead of 1 line. People don't like having more lines than they need to have. And that could really suck if I've got like a classroom of 40 people that I have to delete. Any questions about this? Yeah? I mean, yeah, it would still be correct. It would still free the memory, right? If I didn't set it equal to null. But now if I want to reuse that variable later on, I don't know, I have a pointer that's not null. I don't know if it's in my, if it would give me a seg fault or not. I don't know if that person's dead. Yeah. Okay. So, I'm going to skip ahead a little bit. I mean, I have, this one here is just a print function. Let's just print a person, but I think that's hopefully really easy. So I'm just going to skip ahead a bit. Was there any more questions about that last one? Yeah? Oh yeah, sure, whatever. So yeah, write a function that accepts an array of integers, its length, and loops through the entire array, printing out every value. So far nothing crazy. You gotta set the index of each to a random value. Okay, getting a little crazy. The catch is that you can't use square brackets at all in your code. All right. And I've omitted the function parameters and stuff to this one because I've given you the function parameters for all the other ones. Now I've got to figure that out. What would be the function parameters though? Okay. Does this function need to return anything? Doesn't say so we can just say void. We can name it whatever we want. What did I name it in my cheat sheet? Oh, that's fun. Okay, we can name it whatever we want. So I chose that. And we need to pass in our parameters. What would be the parameters to our function? Int star array. Why not the other type of int array? We're giving it a one-dimensional array this way. Yeah? Yeah, int n. Okay. But why specifically are we passing in a pointer array instead of like an array that, oh, well, yeah, that's right. We can't even use the square brackets. Yeah. Yeah, I gave that away. You can't use the square brackets. The other reason is if it were the array that uses square brackets, it would have to have a number inside of those square brackets. But this function should accept an array of any length, not just one of size 10 or whatever you write in. And you can't put a variable inside that because that's not allowed. So yeah, that's why. So we're definitely going to have a loop. So let's just loop. Okay. So what's this doing with the array? We're printing out each value, and then setting each to a random value. So we print it and then set it to a random value. Okay, cool. All right, here's where it gets weird. So I need to get to array I without using square brackets. How do I do that? Yeah? Yeah, just like in the Kahoot that we had like forever ago. was a long I. Tall I. Yeah, so we just got to do some pointer arithmetic. So we've got our pointer right here, the array. We move I spaces up in that pointer, and then we dereference that address. And we go to, that should give us array I. Any questions about that? Okay. Now we need to set this to a random variable, to a random value. How do I write the next line? No, because rand gives you a random value anyway. You could mod by something, and it would still be random, as long as you didn't mod by 1, because then you would just always have 0. Yeah, that'll give you a random value. And that's it. That's the whole function. Any questions about that? About pointer arithmetic and dereferencing and stuff like that? Okay. All right, this next one is super fun. So I've got a face, and what this code is going to do when we write our portion is it's going to do an animation of the face just like moving in the terminal, just in a loop going in circles. Sort of. It'll wipe off to one side and it'll like come back on the other side. So that's what it'll do, just in a loop forever. The way it does that is it's just a loop that goes on forever. It calls shift Squidward, which we have to write. It sleeps for 1 second. This is a function that you can call on any Unix machine. So I don't think this function exists on Windows. Sorry. You have a different function on Windows. It's like Windows sleep or something. And then I just print Squidward. And then I just print some new line characters. Yeah. So we've got to fill in print Squidward and shift Squidward. Any questions about what we have to do? Yeah. Is it any specific library for your sleep? Oh, what library is it? It is UniSTD. It's not a library you need to know about. Yeah. But that's where sleep comes from, if you were wondering. Okay. So let's start with print Squidward, because that's got to be the easiest one, right? Also notice how Squidward was declared with pound defines of the height and width. So we get to use those. All right. I'll just say squid, so I don't have to write word. Okay. So print Squidward is really simple. How do you think we should do print Squidward? Yeah? 2 nested loops? What if I said we only have to do 1 loop? How would we do just 1 loop? So we have a 2D array of characters, right? Yeah? Yeah, just one for loop, yeah. We don't need if statements. We'll just have one for loop with one printf inside. So we have a 2D array of characters, right? So if you just look at, say, the first dimension of the array, what is each index in that dimension storing? Yeah? Oh, we don't need to do that either. We're just going to loop by just while I is less than height. And this is the whole function. There's going to be a printf. Yeah? %s. Yeah. Each index of the array just holds a string. So you just print each string like that. It's easy. You could have done the double nested loop, yeah. And then move into %c. And honestly, maybe you should just do that, because if that's what's most, because you got a time crunch on the exam, right? So maybe just go for the most obvious thing instead of thinking for 20 minutes about, oh, %s. Even though it is so simple, it's clearly not simple if it takes you that long to figure it out. So yeah. Okay, print Squidward done. Now we need to do the hard part, shift Squidward. So shift Squidward, I told you, whoop, I didn't tell you. It shifts him 1 character to the left. So like the whole array, just 1 character to the left. Does that make sense? The whole array, just 1 character to the left. And we need any deleted things on this side to reappear on this side. Okay, so that's what we need to do. Any idea of how we can do that? So there's going to be some loops going on, yeah. Let's say that we just need to swap. Dang it! I just gave it away. We need to shift. Let's say we just need to shift this 1 row, okay? And we need to shift this whole thing over, so this whole thing shifts over, and this one on this side, right on the edge, reappears over here. Yeah? Uh-huh. I'm not sure what you mean. Uh-huh. Mm-hmm. Okay. I'm not following. So that maybe is a hint that you didn't solve it the same way I did. And we're gonna solve it the way I solved it, because that's the way I know how to solve it. Sorry. Let's just take this step by step, and we'll cross this bridge when we get to it. So, in this case, we do need to worry about this thing on a character-by-character basis. So we are going to have a double nested loop. I'm just going to call them S now, even more abbreviated. I'm just going to use H and W also, because so we're going to have a double nested loop. Okay. It's actually the end of the function there. Okay. So we're just looping through the entire thing now. So let's say we're at this character here. Let's say we're at this character here. We need to essentially, let's say that, so if we're at this character here, let's say we've already moved this character over here now. Another one of those characters over here. We now need to get the next character and move it into here. How can we do that? Because if we have a way to just move like just one character one to the left, right? We can just keep calling that function over and over again, right? Just plus one, right? Okay, you're on the right track. So you're saying like, so our array is named S. S sub I j is equal to S sub I j plus 1, like that. What was that? No, we're just doing the whole array to the left. Yeah. We could just write, I guess we could write -1, and that would be a different function now, and it would go to the other direction instead. Yeah. This is on the right track, right here. Let's assume that this works. Do you see any problems with this? This would shift it to the... Hold on. This definitely shifts it to the left. Because see, what this does conceptually is you go at this current index, I go to the next index and just move it in. Yeah. So there's a problem with this line right here. Yeah? Uh-huh. Yeah, because at the very last index we'd be going over. Is that what you were going to say? No? Okay. Yeah, but at the very last index, we're going over here, right? So what can we do to fix that? Put inside an if statement? Well, if we're always just not going to the last index, right? What if we just change how far our loop goes? Just the width minus 1. That way we just don't go to the last index. And we'll worry about that at the end, like outside the loop. We'll just do that. There's something else. Something else that you probably wouldn't notice from like looking at Squidward's face, and you probably wouldn't get from counting because there's spaces and stuff that would suck to count. But I think you could be expected to infer this just from how much you've been seeing strings all semester. The width is 28, but do you think that there's actually 28 characters typed out here? If you had to guess, how many characters are typed out here? You have to guess. You literally can't count because there's spaces that you can't see. So you have to guess. If there's not 28, how many do you think there are? On any line, there's... Well, okay, so the thing is with these double slashes, I couldn't do just a regular slash because C didn't accept that. But if you do 2 slashes, that actually creates a slash character. So anytime you see 2 slashes, that actually means just 1 slash character. So yeah. But someone said it. How many characters do you think there are if you had to guess? 27 per line. Not 28, 27. Why 27 and not 28? Because of null terminator. So there's an invisible null terminator at the end of every single one of these lines. What would happen if we were, like, as we're rotating this string, right, we're shifting it all one to the left and we're wrapping it back around to the side? What would happen if we also shift the null terminator with it? We wouldn't run into any segmentation faults or any errors or anything. Like the code would run and the code would think that it's cool, but it totally wouldn't be cool. It just would not print, or it would print but not correctly. because that null terminator would be like stuck in the middle at some point, right, as it's getting shifted around and rotated. So as we do this printf here that uses %s, this printf with a %s, it's going to keep printing the string until it sees the null terminator. So it's just going to it's just going to keep printing Squidward until it gets to like in the middle, and then it's going to stop. And then you won't see all of Squidward's face again until we finally rotate the whole thing back around, and we've got the null back at the end again. So that would be wrong. Yeah. So what we can do really quickly to get around that is just instead of -1, but it's -2. So now we're both ignoring the null terminator at the end and the last character also. So it's taking care of this null problem and the problem that we were seeing before. The going out of bounds problem. Yeah. And the other part of solving that going out of bounds problem is actually swapping the character at the very end. Yeah. So I think someone said, what if we did like an if statement? This is what we would have done in the if statement. If we did like, if we're right at the end, do this is what we would have done. But we don't need to do that if, because we can just not go to the end, and then always at the end just do this. Any questions? Do you want to see it running? Oh no. There we go. And that's it. That's what we've been working towards. You can clap now. Okay. Or you can not clap. Maybe it was just really lame this whole time. You've just been sitting here like, why is this dude just coding with Squidward right now? He's so lame. Because what it's actually doing is, it prints all these new lines, right? It prints shift Squidward, sleep, print Squidward, then it prints all these new lines. What it's actually doing is it just prints Squidward, and then there's just exactly enough new lines so that the new Squidward that prints out is right where the old one was, and this is the old Squidward up here. So it's actually just printing a gazillion Squidwards over and over again is all that's happening here. And that's how terminal animations work. If you've ever like seen a loading bar or something as you're trying to install something, it's just a very advanced version of this. Any questions at all? Like not about my review anymore, like just about the class in general. Any dying questions before the exam on Monday that I didn't go over? An array of struct pointers. Dynamically allocated. Okay. Okay, let's say I have a human. Oh, here's a student from the from my Kahoot, so I'll just do that. This is bad because it's not at the top of my main, but whatever. So if I've got a student, I want to make an array of them. If you're doing a dynamic array, it's always going to be a pointer. And we gotta do it dynamically, right? So it's gonna be size of students and just however many of them you want. So maybe I want, how many of us are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 28 of you. So there you go. Well, I've already got an int I somewhere. Equals, what do you want to do? Any value besides a what? What? Each iteration. Oh, so you want to go specifically, like you want to go to student I's ID and do something. Like that. Yeah, you can do that. Oh no, what's it saying? Oh, students. There. And that goes to students I, sets this ID to whatever, and that's how you, yeah, that's how you do that. You can do the dot after brackets, is I guess the answer to the problem, the vague issue that you're having, the nebulous programming question. Any more questions to do with the course? Okay. No questions. Everyone's like, I'm going to ace this exam Monday. There's no question. You're just going to go home and like watch YouTube for the rest of the weekends, right? Because you're just so sure about your A on Monday that you have no questions right now. Yeah? Any last tips? Like, don't stay up until 4 a.m. tonight studying, or tomorrow night, obviously. Like, get a good night's sleep tonight so that tomorrow your sleep schedule will let you get to sleep at the right time. Eat a good breakfast. I probably sound like your mom right now. But there's like studies that say that that's like real, that sleeping right and eating well has a direct impact on grades and stuff. So while you're studying, like write stuff down on paper because your exam is going to be on paper. So how I always study for my programming classes is I just like sit down in a nice comfy chair with a notebook and pen and I just write code and stuff on paper. And then when I feel like I've written enough, I get up and go to my computer and copy it into the computer and make sure that my code I wrote by hand actually runs and is solid. That's how I study for all my programming classes. Take a look at my other reviews that I have on my WordPress because they're still relevant and his exam is cumulative and you could test you on any of the things from those reviews. And I know I had like I always put hard problems in my reviews. Like I think that one where you had to reallocate the array that we did today probably sucked. But better to overstudy, right? Look at problems that are way too hard that he probably won't ask you. And if you can get those, then you're going to be fine in the exam, right? Hopefully. Yeah? You should expect them to be harder. That way you're definitely going to be fine if they're easier than my problems today. Yeah. I always assume that the problems are just going to be the worst. That's what I always do. I don't know if that's like a nihilistic approach to studying. Just always assume that the exam is going to be unsolvable, that no one can possibly get an A on this exam because it's going to be so hard. Because if I just assume that and then I just study as hard as possible, then I know I've tried my hardest. But I guess if you want me to set your mind at ease so that you just don't stress, the exam's going to be a cakewalk, man. Yeah. But that was me setting your mind at ease. I was lying. I have no idea. Struct pointers. Okay, easy. So it's a struct pointer now. That just means I need to make, before I was making space for a student, right? Now I need to make space for student pointers. Because this first dimension, it stores pointers. Each index stores pointers. So I need to make space for this many student pointers. Now I can't do this anymore. I have to do an arrow. But I also can't do this because this would segfault, because each individual index hasn't been allocated. There you go. So now every single index is just enough space for one student. And I can just go to that index and change their ID like that. Yeah. And I guess if I wanted to, I guess this is where it gets really ugly, is if I wanted to, I could use the same array, the same double pointer, to instead now store a 28 by 28. Like that. Which could get like really confusing, because that means that given your double pointer array, you don't know if it's an array of pointers or a 2D array. And you don't know unless someone tells you. Because if you try to find out, you'll get a segfault. Yeah? A dynamically allocated memory address? Yeah, we wrote like 2 today that did that. The one that makes a person. Oh, yeah, create person. So this create person function creates a dynamically allocated memory address. Because we call malloc on person, and that's what we return, is this address that we allocated. Yeah. Do you remember at all if this is something that can be done? Actually, wait. No, never mind. Never mind. I was thinking of the other class I SI for. I also do SI for CS1. Yeah, my bad. But yeah, that's a function that creates a dynamically allocated memory address. Mm-hmm. What was that? What time I'll upload the solution? Today, like 10 minutes after this, probably. Yeah, at least 30 minutes. Hopefully I'll print it by then, by 7. It'll be on my WordPress, just like all my other reviews that you can look at and study. You've got like 10 more minutes that I'm going to stick around here if you have any more questions. Yeah? Pointer to a nested pointers and structs? Yeah, okay. So I have my... Do I not have a... Oh, here it is. So here's my structs for person and height. So, oh, they're just right here. I could have just scrolled up. Here they are. So I've got a person, and you're good on this, right? I just have a person, and I go to their name, and I go to their height. Well, if I have a height, like let's say I could have declared a height like this. Like that. I could have declared a height like this, then I could have done like height feet equals feet, height equals inches, like that. And is this good to you? No questions here? Okay. Well, the same thing is happening right here. This line is the same as this line. I just go to the person's height, and I make space for a height, instead of declaring a new height. The person already has a height pointer right here. And then for this height variable, I go to its feet, and that's the same thing as this height, and going into its feet. Yeah. Actually, what I could have done at this point, if you wanted to do it this way, I could say person height equals height. And it would have been equal to this height that I made up here. Yeah, this would be totally correct. Just a different way of doing it. You just make this variable that you only use to store some space. Yeah, temporarily, to hold on to this pointer. And then you can just reach it like this. And if that's something that you're more comfortable with, then doing 2 arrows, like going too deep like that, then that's fine. This is also a correct way to solve the problem. Okay. Did everyone fill out their survey? Did anyone not get a survey? You didn't get a survey, you didn't... I don't know. I'd say just don't fill in anything. I don't know what that should be. Did someone not get a... You didn't get one, you said? You didn't get one. Okay. There you go. There you go. There you go. Everyone get one? Okay, you two don't have one. And I'd say just leave your surveys on the table. I'll pick them up. There you go. There you go. All right. Good luck on Monday.